the riverbed goes down, these launching aprons, because they are loose stones only, so they launch themselves in this slopy fashion, and now they are not called the launching apron, rather they are known as launched apron, because they have launched themselves in the desired position. So this is a stone pitching, you can say, the stone layer here, which protects the structure, which protects this particular soil in this area to get scoured out because of the scouring activity flowing water. So this slopy portion of stone, it provides protection to this entire structure. So the structure is not damaged. It protects the structure. When the flood wave passes and the normal flow conditions prevail again, so this will not come back. It will be there, but it will keep protecting. Now, when the normal conditions will prevail, this this bed level may start building up again because of the deposition of the sediment that comes from the side. But this launched apron will remain in the position of the launched apron, and it will keep protecting. Because the river bed is loose, unconsolidated, and cohesionless material. So these loose stones can go further deeper also, and the exact layer may not be maintained in future also. So we keep on adding more and more stones over here, so that in case of the floods, launching apron keeps its function on, and it keeps protecting the entire structure. So here we have one text also, that after the river covers out the bed, the launching apron launches itself, provide a protective armor layer, the slope of 2 horizontal to 1 vertical, and is called launched apron. Okay, so the slope of this particular launched apron is 2 horizontal to 1 vertical. That means whatever the depth up to which the river has covered out, so twice that depth this horizontal will be there, so it will be sloping in the with this slope horizontal to 1 vertical. So we have to design this launched apron or the launching apron so that in eventuality of flood, it will launch itself into this slope. Okay, I think up to this point it is very clear to you. So here, let us discuss more about the launching apron. So the scoured section provided for some components of hydraulic structure in the form of a stack of loosely packed stones. So it is a stack of loosely packed stones. So here the stones are not joined together in the form of stone masonry. They are not joined in mortar. They are loosely placed stones. Okay, so it provides a scour protection to some components of the hydraulics. Here it is providing the safety to this sheet and this floor only, but actually when we provide the scour safety to some component, ultimately it is meant that the entire structure is secured. So that safety is extended to the entire structure. So it provides the protection to the entire structure. So it is provided in the form of loosely packed stone on upstream and downstream end of the structure. So discuss it that on both of the sides we have provided these launching aprons. If you zoom in this portion and see it in the bigger view, so this is the view of the downstream protection. Similar will be the case with the upstream protection. So how to design this launching apron. See, it is the launching apron as laid. This is how we provide the launching apron. Okay, we provide the launching apron in this fashion. Some thickness is provided and some length is provided, and perpendicular to the screen, it will have the length equal to the total width of the channel. Okay, so that we'll be discussing later on. If the water is flowing above this, up to the HFL. So what will happen? The water, because above this floor, the water is up to this HFL. Now I have removed this shading. The depth of the water which is flowing above this launching apron up to this HFL, that is, let us say it is Y. Okay. So depth of flow is capital Y over here. So Lacey's regime's cover depth, if you calculate that how deep this riverbed can go, how deep this riverbed can go. So for that, Lacey has suggested this cover equation 1.35 Q by F, sorry, Q square by F raised to power 1 by 3. Okay. And it is measured from the HFL. So this R is the regime's cover depth below this HFL. That means this R value is measured from this HFL in the downward direction. So if the, let us say the river bed will be coming up to this level, from this level to this HFL, this entire will be R. Okay. So this, with this equation, you can calculate the regime's cover depth. Here, small q is the discharge intensity. Discharge intensity, I'll be explaining it later also, but as you know in the fluid mechanics also, discharge intensity means the discharge passing through a 1 meter width of the channel, not the entire width. From the entire width, the total discharge capital Q passes, but from 1 meter width of the channel, how much discharge passes, that is small q. Okay. And this F is silt factor, and it is determined or it is calculated by this formula 1.76 under the root D50. And D50 is the median particle size of the riverbed material. Okay. So 50% of the particles are finer than this size, and 50% of the particles are coarser than this size. So that particular size is called D50. So if that size is determined with the help of sieve analysis, then square root of that D50 size multiplied by 1.76, that will give you the value of silt factor F. And that F is to be used over here. So we will work out the value of R. So this is the value which is suggested by Lacey, but we have to multiply this value of R by some safety factor. So that safety factor X ranges from 1.25 to 2. Okay. So 1.25 to 2. So how this factor varies from 1.25 to 2, it is recommended for different situations, different value of X is recommended. So in the sequence slide, we're discussing that also. So X times R is the total cover depth below HFL. So if you subtract this Y, okay, so that will be maximum possible cover depth below floor level, because this R or X times R is below this HFL. From this, how much deep riverbed? Okay, from this floor level, if you want to calculate, you have to subtract this from this. So XR minus Y is the depth of scour below the floor. So from the floor level, how deep you have to go, that is capital D. Okay. So how this Y is determined? HFL minus floor level. So it is very simple. High flood level, if this level is given to you, floor level is given to you, so difference of these two levels will give you the flow depth. So this is D now. So this D we have provided over here that what bed level will go this much deep, okay, up to this level. So this is the probable deepest scour level in the eventuality of the flood, when the design flood will come, according to Lacey's regime theory. So it will have the tendency to move up to this level. So this bed level will go at the most up to this level, not beyond that. Okay, under no circumstances the bed level of the river will go below this. Okay, so this is the probable deepest scour level. Okay, if deepest scour level is there, then this depth D is same as here. And if you see a point over here which is at a 2D distance from this initial level of this launching apron, because it has to launch itself at a slope of 2 horizontal to 1 vertical. So twice d here and 1d over here. So this will be the slope like this. Okay. So this launching apron, because this launching apron is launching apron as laid. This is what we provide. But in case of discovering, in the case of flood, it will launch itself into this position. So this is the launched apron. So launched apron will be of this shape. And if you see this top line, it is up to this deepest scour level. And this horizontal dimension is twice d. And this vertical dimension is d. So in this particular triangle, we will be doing some calculation. So this launching apron is supposed to maintain its thickness 1 meter. So that is also in the guidelines that at least 1 meter thick launched apron should be there. And if this is 1 meter, so we'll be using this 1 meter in the calculation of the quantity of stone. So, but if you see this angle, height is d, base is 2d, then this dimension, how long it will be? Can you calculate it? Okay, you have to calculate this value. Okay, if you have calculated it, I have launched a poll. Answer it fast. How much will be the value of that question mark that I have shown? I am sharing the result that you have given to me. See, 9 students are saying that it should be 5D. 7 are saying it should be D. Its value is 2.25D because it is a right angled triangle. Simply apply the Pythagoras theorem, square of this dimension plus square of this dimension, that is equal to square of this dimension. So D square plus square of 2D, that is 4D square. So 4D square plus D square, that becomes 5D square. So 5D square is basically square of this side. So if you square root, take the square root of 5D square, it becomes under root 5D. And under root 5D is the value equal to, right?
No, sir.